All right, friends, so today we're going to talk about parabolas. I know we already know how to graph parabolas. Now it's very similar, except we have a lot of new vocab and we're thinking about parabolas from the conic perspective, so there are some things that are different. So a parabola is a set of all points x, y that are equidistant from a fixed line. That fixed line is called the directrix, and a fixed point called the focus point. So as you can see in this picture, any point on this parabola, so maybe I pick one here, the distance to the focus and this directrix, those are going to be equivalent. Our parabolas, so our vertex is the midpoint between those two things. So the midpoint between my focus and directrix is the vertex of our parabola, and our axis of symmetry is the line through the focus and perpendicular to the directrix. Lots of new vocab, but we'll talk about it once we get there. We are going to be dealing with parabolas that open to the left and to the right. So a couple of things. Now I won't go over all of this because I think it's a little more confusing and just better to kind of see what's happening. So if we have x squared, our parabola is going to be just like any one that we know. So we're either going to open up or down. And if I have y squared, we're going to open up to the left or the right. How do I determine that? Well, if this p-value here is positive, we're going to open up or right. So where those positive numbers are on our x-axis. If p is negative, so if this number in front of the thing that's not squared is negative, then we're going to open down or left. I'm not going to talk about these because I think it's better to just kind of do it. Okay, so our focus lies on the axis of symmetry and lies inside the parabola. The focus is p units from the vertex. The directrix is perpendicular to our axis of symmetry. A focal chord is a line segment with endpoints on the parabola containing the focus of the parabola. We don't do much with the focal chord. A focal chord would look something like this. Maybe you have a parabola here, and let's say this is our focus. A focal chord could be any segment that goes through that point but lies on each side. Whereas our latus rectum is what is super important for us. Let's say my parabola opens this way. My latus rectum is perpendicular to your axis of symmetry. So my axis of symmetry would be here. My latus rectum is going to help us find 2 points on our parabola. Okay, so let's just do a couple examples. Here we go. So it's already graphed for us, but I'm going to talk about where these things are coming from. So first of all, y squared. I have y squared, so that tells me I'm either opening to the left or to the right. Because this value here is positive, I'm opening up to the right. My vertex is coming from here and here. The 3 is with my x value, the 1 is with my y. So that tells me that my vertex is here at 3, 1. I know I'm opening right. We just talked about that. My axis of symmetry is going through my vertex. My axis of symmetry is splitting my parabola in half. So that is the line y equals 1. I have to find P in order to find my focus and my directrix. I have to find P in order to find my focus and my directrix. So this number here in front is always equal to 4P from the equations above. So from here and here. So 4P is equal to 4, which means P is 1. What does that tell me? That tells me that my focus and directrix are a distance of 1 away from my vertex. So my directrix is a line that is perpendicular to my axis of symmetry. So because my axis of symmetry is horizontal, my directrix is going to be here. I'm a distance, this right here is a distance of 1. And from my vertex, I also am a distance of 1 to my focus point. My focus point is 4, 1. Notice I'm adding 1 to the x value. And my directrix is x equals 2. It is a line. So we'll go over here. My focus is 4, 1. I've got x equals 2. Now to find the length of our lattice rectum, we take 4 times p. It's a length, so it's always positive. So the length of that is 4. Now how does that help me? That helps me because from my focus point, it is a length of 4 to touch both sides of my parabola. So I'm splitting that distance 2 and 2. So from my focus, I would go up 2 and down 2. And that's going to help me draw my parabola. So this entire thing is a distance of 4. And our equation is here as well. All right, I know that was a lot, but let's look at the next one. We're just going to try to do, we'll see, maybe up to example 3, maybe 4. Okay, example 1. I need to turn this, I know we can graph something like this, but I want us to turn it to look like what we had on the other page. So getting our squared by itself on one side. So what we're going to do, typically you'll be given the question like that, but I'm going to subtract the 1. Again, my objective is to get my squared term by itself. And then I'll multiply by 8. So I have 8y minus 1 is equal to x minus 2 squared. Because now in this case, my x value is squared, that means I'm either opening up or down. Because this 8 is positive, we're opening up. My vertex, 2, 1. So I'm going to start there and plot that vertex. My focus, this number is equal to 4p always. So p is 2. That means the distance between my focus and my directrix is 2. Since I'm opening up, my focus is always inside my parabola, so I need to go up 2 for my focus point. So 3, 2. Sorry, 2, 3. Backwards, Misty. And then for my directrix, I'm going to go down 2. And again, since I'm opening up like this, I'm going to have a horizontal line because that thing needs to be perpendicular to my axis of symmetry. So I have that at y equals -1. My axis of symmetry is going to go straight through these things. So x equals 2. Now 8 is the length of my lattice rectum. 4p is 8. So the length of that is 8. Now how does that help me? Again, this is going to give us more points on our parabola. From my focus point to points on my parabola, it's a distance of 8. So I need 4 on each side, which will give me my parabola here. So remembering this is our focus, our vertex, our directrix. This is the length of my lattice rectum, which is 8. All right, nice work, my friends. I'm sure you're doing great. All right, find the standard equation given these things. All right, draw a picture. I know we don't have a graph, but we can draw a rough sketch. All right, my vertex is at 3, 5. This is my vertex. And my focus is at 3, -2. Now this distance from my vertex to my focus is my p-value. Well, 5, how do I get from 5 to 2? It's a distance of 7. My parabola is opening down. How do I know? Because my focus lies inside my parabola. So that means my x needs to be squared. Now, how do I figure out what goes here? Well, it's 4 times p. 4 times p is 28. But because it's opening down, I've got a negative. All right, I was going to do 3 and 4. We're just going to do 3 because I'm running out of time. I don't want to make it too long. So 4, 5, 6, and 7 we will save for Monday. All right, notice when I'm completing the square here, only one thing is squared, which means that everything else I need to move to the other side. So I have 2y squared minus 8y is equal to 4x minus 3. To complete the square, we take out the 2 plus blank, which I still need to remember to do that over here. B divided by 2 and square it is 4. So I'm left with 2y minus 2 squared is equal to 4x. Negative 3 plus 8 is negative 5. I'm almost there, but not quite. I've got 2y minus 2 squared. I need to factor out this 4. So I've got x minus 5/4. Remember, factoring out a 4 is we're really dividing everything by 4. Check your work, distribute, distribute. When you multiply 4 by negative 5/4, we've got 5. And then last but not least, I need to divide both sides by 2 because in standard form, you need to have your x squared by itself. So I'm left with y minus 2 squared is equal to 2x minus 5/4. So this right here is standard form of our parabola. Now I can answer these questions to the left. So my vertex, I've got negative 5/4, comma 2. My focus, well, I've got 4p is equal to 2, so p is equal to 1/2. Now we have to figure out, well, my y is squared. That tells me that we're opening to the right, or left, sorry. Right, because 2 is positive. So my focus is a distance of 1/2 inside. You could try to plot this. Negative 5/4, 2. I'm opening this way. So my focus is 1/2 a distance away here. So from my x value, I'm going to add 1/2. So I have negative 3/4, comma 2. My directrix is a vertical line this way, and I'm moving a distance of 1/2 to the left. So negative 5/4. Take away a half. I've got x equals negative 7/4. All right, my friends, I will be back on Monday. Please make sure you are attempting to figure these things out. I will be there Monday to answer any of your questions. I hope you have the best weekend ever. All right, bye.